Hey, what's going on, everybody? I'm not going to start right away because yesterday we had almost 30 people here, and it's showing on my end that we got about 11 or 12. So I'm just going to give a second for everybody to catch up on in here. Let me turn off the light. This is bothering me. I got a glare on my screen. Hey, what's going on, Tabitha? Hey, Zuchi. What's going on, guys? Long time no talk to. I mean, we got a handful in here. I might just start going with the lesson, and then hopefully by the time we get to the new part for today, we'll have enough people in here. Lessons are going to stay here on Twitch. Some teachers are going to Zoom. I'm staying on here. Hey, what's going on, guys? Yeah, Zoom is only going to be for office hours. So if you guys want to have more of an interaction with me for asking homework questions at 1 o'clock, I think the 1 o'clock time slot, I'm going to just stick with Zoom. I'm going to do it for an hour. The only reason I like doing the homework on Zoom is because the questions are more like instantaneous. You can ask the question and I can have it up on the screen as I'm writing. There's no delay. I like doing Twitch better as well. I'm hoping we can continue doing it. Twitch is not considered a educational resource. So if like Mr. B or administration comes to me and says I can't do it anymore, then we're going to be forced to switch over to Zoom. I would like to continue using this. A lot of you guys are showing up to these live videos. A lot of you guys are watching my videos afterwards, either on Twitch or on YouTube. And I think that for a lot of you guys, it's been beneficial. But that's just my opinion. I have to do what the boss says. So we'll see what happens. Yeah, it seems like a lot of you guys have preferred this. I was talking to my wife and her students as well, and they said the same thing. They really like how this whole thing is set up, and you guys can still ask questions if you need to, and otherwise it's watching a video live, if that makes sense. But I don't know. It looks like we had a handful of people in here. I'm up to, it says 16 viewers on my end. Yeah, we could go. I'll start the lesson. So we're going to finish lesson 9, which is, those are homework number 9s. Where's lesson 9? There it is. So anytime I go to finish a lesson with you guys, what I like to try to do is just kind of slowly scroll through everything that we've done so far. Just in case if somebody missed the video from yesterday, then they can at least go through and they could see this. Yeah, I agree. Zoom can get very confusing when there's a bunch of people in there. I would have to like force mute everyone just so I could try to teach the lesson. So I'm going to start today on exercise number 2B. Now, I'm telling you guys, when we did 2A yesterday, that's going to be the hardest one you guys will see. I promise you guys, when you start looking at the ones that are on the homework, when you start looking at even the ones that we do today, it's not going to be anywhere near as difficult as what we did in Part A. And even so, I'm not really saying Part A was difficult. It was just there was a lot of steps. So I like using the word tedious because there was a lot of different steps that we had to do to solve it. And the reason why is because we had 3 separate denominators. We had 3 denominators that were completely different. A lot of the ones that I'm going to give you guys, they're going to be similar denominators, and it makes life easier. And that's what's going to happen in Part B here. Well, I'm glad you guys like this. I mean, I will continue doing it as much as I can. Hopefully, like I said, administration stays okay with it, and we can just kind of go with it. Let's see here. So, when we go to reduce complex fractions, we have to make sure that we get those LCDs. So we only have 3 fractions here. Before we can do an LCD, you have to make sure all those denominators are factored first. So if you look at the top ones, that x plus 6 and that x plus 2, You can't factor those. Those are already simplified down. However, if you look at that last one, we can simplify it because we'll have x squared plus 8x plus 12, which could really be factored into two bubbles. And it looks like it's going to be an x plus 6 and an x plus 2. So what I'm going to do is I'm just going to kind of cross off that denominator that was there and switch it to that x plus 6 and x plus 2. And you know what? Just because it looks kind of messy, I am going to rewrite the whole thing off to the side. I know it's kind of, like I said, tedious like the previous problems, but I want to make sure everybody is seeing exactly what I am doing. So all I did is I factored that denominator out. Because now what we need to do is just find the LCD. No, you don't have to do the shortcuts here. So now we just got to find the LCD. And if you guys look at those denominators, we have an x plus 6, an x plus 2, and on the bottom, we have x plus 6 and we have x plus 2. So we can justify saying that the LCD for this problem, I'm going to shrink this down a little bit so I can fit in the LCD. The way this shortcut works is once you find the LCD, you just have to multiply all the fractions by that LCD. So if there's no questions, I'm hoping that we're seeing that the LCD has to be both of these binomials. It's got to be both because the bottom denominator has both of them in it. So what I'm going to do is multiply every single fraction by this x plus 6 times x plus 2. And this is like the super shortcut because we only have to write out the LCD once for every single fraction. Based on what we were doing the other day, we were writing it on top and bottom because whatever you multiply to the bottom of a fraction, you have to do to the top. So you're technically writing more when you do it that way. It's really based on preference. If you guys feel comfortable with what you did the other day, that's fine. It was only a 30-second ad. So now, because we're multiplying these fractions, I'm just going to put all of these over 1. And if we look at the first fraction, we have an x plus 6 on the top, and we have an x plus 6 on the bottom, so you're allowed to cancel those out. So you're just left with x times x plus 2. In the second one, we have an x plus 2 on the top and an x plus 2 on the bottom, so those cancel out. So then we have minus 1 times x plus 6. And some of you guys may distribute all in this one step. Again, for note purposes, I'm just rewriting it all. And then on the bottom, you guys have the x plus 6, x plus 6, x plus 2, x plus 2. All of those cancel out, and we're just left with x squared minus 4. So again, some of you guys may have already distributed. I'm just showing it out in steps so you guys can see note purposes. There's a lot of shortcuts you guys can take with these type of problems. I just want to make sure that you feel comfortable doing so. So now I'm going to distribute it through, and I'm going to have x squared plus 2x. And make sure when you go to distribute through that 1, it is a negative 1. So we're going to be having negative x minus 6 all over that x squared minus 4. And technically, some of you guys are probably already seeing x squared minus 4 can be factored. So you can split it up right now if you want to. So I'll have x plus 2, not x plus 4, times x minus 2. And now the rest is just combining like terms and factoring to see if anything cancels out. So now we can do the top, and we're going to have x squared plus x minus 6 all over that x plus 2 and x minus 2. And now if you factor the top, we can do two bubbles for that, and it looks like it's going to be an x plus 3 and an x minus 2 all over that x plus 2 and x minus 2. And again, you should see that some stuff cancels out. Those x minus 2's, you have one on the top, you have one on the bottom. So they're gone. And we're left with that final answer of x plus 3 over x plus 2. So I added in a couple of extra steps here for note purposes. I added in 2 extra steps. Some of you guys may want to show every one of those steps because it will help you understand it a little bit easier. Some of you guys be like, I know how to multiply x times x plus 2. I didn't have to write that out in this step right here. And that's fine. If you can go from here down to this step, you could skip right over it. Some of you guys may have went from right here down to this step. And that's okay. Whatever you feel comfortable with. Okay? So everything I'm going to do on the back is going to be very similar. It's just I'm adding in negative exponents. And we don't like negative exponents, so we're just going to have to get rid of those. But right now I'm just kind of talking to fill in the gap just in case if anybody has any questions on what we just did on part B. And I could go back and answer those if you have them. Yeah, a lot of you guys showed up today. I'm checking the viewer count. We got about 20 people in here. All right, so I'm going to scroll down. I'm only going to do A and B. I am not going to do this complicated one with you guys right now. So number 4, I'm going to skip over. Maybe what I'll do is I'll just do like a short recording of it showing you guys how it's done, and I'll just send it out rather than do a whole lesson on it. But basically number 4 is taking everything we just did on the first page, but we have to do it twice. And like I said, I'll send out a video with that. It'll probably be like a 5-10 minute video showing you guys how to solve a problem like that. But anyways, so I'm going to go down to exercise number 3A. And you guys have always been taught that, 99% of the time you don't want negative exponents because negative exponents are bad. So we have to make them positive. The common mistake that I see in these type of problems is what you're going to want to do is take this x to the negative 2 and go, oh, well, if I want to make this positive, I can just flip it to the bottom. However, that's not the case here. We're not allowed to do that because you're only allowed to do it, like we said the other day, everything has to be multiplying all the way through. You can't have a minus and plus sign in there because then you can't flip it to top and bottom. Just like I said the other day, you can't cancel stuff out unless everything's multiplying. You can't flip stuff over unless everything's multiplying. So you can't just flip it to the bottom. However, what you can do is just look at this x to the negative 2 separately. So if I were to write x to the negative 2 off to the side, we can rewrite that as a fraction. X to the negative 2, if you guys recall, when you want to make a negative exponent positive, you have to put it over 1 and flip it over. So if I flip this over, it's going to become 1 over x squared. So instead of flipping it to the bottom of the fraction, what I'm really going to do is I'm still going to have my big complex fraction, but I'm just going to write it as 1 over x squared on the top. And now I'm just going to do all the other ones. So now I'm going to do y to the negative 2. So I'm going to put in my minus sign. And I'm not going to keep writing them off to the side like I did with that first one. But y to the negative 2 is just going to be 1 over y squared. And now I'm going to do the bottoms. Same thing. X to the negative 1 is just going to be 1 over x to the first power plus 1 over y to the first power. So if anybody's lost with that, make sure to put something in the comments so I can help you out there. But all I did was change them and made them positive. The rest of this problem is like we just did on the first page. Now, in order to get rid of all those mini fractions, we have to do an LCD. So I'm going to look at all those denominators. So I have x squared, x, and y. And what I want to do is find the LCD for all of them. When we did variables, we said in order to find the LCD for the variables, you pick the larger exponent. So I have x squared and I have x. So I know that I have to have x to the second power because I have to have at least 2 x's in all those denominators in order for the LCD to work. Same thing for the y's. I have a y squared and I have a y. So I know that I have to have 2 y's because that is the larger exponent. So my LCD has to have a x squared, y squared. Okay? Now that I know the LCD, I'm just going to write x squared, y squared next to all of these fractions. And I'm just going to take them all and put it over 1 because we're technically multiplying. So if you guys look at the first one, we have x squared, y squared times 1 over x squared. Just like we did in the previous problem, you guys should notice, hey, we have an x squared on the bottom. We also have an x squared on top. So we can cancel those out. So the very first fraction is just going to be y squared over 1 times 1, which is y squared. Minus, and the second one, you guys have a y squared on the bottom and a y squared on the top, so those are gone. So it'll be minus x squared all over. Be careful on the bottom because you only have one x on the bottom. So you're only allowed to cross off one x on top. So you still have an x left over. So it would be xy squared. And in the second one, we only have one y on the bottom. So we're only allowed to cross off one y on top. So we're left with plus x squared y. So from here, we just have to do our factoring, see if anything cancels out, and then we're done. Top part, you have x squared minus y squared minus x squared. Make sure you guys are recognizing that that is dots. Difference of 2 squares. They're both perfect squares. So I could split them up into 2 pieces. I'm going to have y plus x and y minus x. All over, and if you guys do the bottom, it looks like all we can do is GCF. So we could pull out an xy on the outside, and we would be left with a y plus x on the inside. And in this case, you guys should see the y plus x's are going to cancel out because everything we have now is multiplication. Y plus x times y minus x. X times y plus x. Now that everything's multiplying, you can cancel. So what color have I used? I'll use orange. So those are going to cancel out, and we're just going to be left with a y minus x on the top and an xy on the bottom. Done. So the only new portion that we did today were those negative exponents. That was it. All right. So again, I'll give a second. What I decided to do today is I put my stream on my second monitor. So now I can check to see if there is a slight delay, and it's about 3 to 4 seconds. What would you do if they had odd exponents, the y? So Tabitha, are you saying if it was like y cubed minus x cubed? I don't know if that's what you mean by odd exponents. When you do difference of 2 squares, they have to be even because only even numbers will give you perfect squares. So like if it was y to the 4th minus x to the 4th, you can do y squared and x squared when you split them up into the 2 bubbles. If you have x to the 3rd and y to the 3rd, you can't split those up into 2 separate bubbles because then it would be 1.5. And then you're going to start working with radicals, and then it's no longer a perfect square. So hopefully that answers your question. Eventually we'll go into something called perfect cubes. Actually, you know what? We'll go into perfect cubes if you take Math 12 or pre-calculus next year. We don't do perfect cubes in Algebra 2 anymore. I forgot. It used to be in Algebra 2, but they took it out for the Common Core. All right, so now I'm going to go over to part B. So part B, same type of problem. We want to change all those negative exponents. If they're both cubes, Tabitha, you couldn't simplify it. You would just have to leave it. So now that we're in part B, same type of problem. That top is x in the negative 2. We don't want that x in the negative 2. So what I'm going to do is I'm going to draw out my line. That x to the negative 2 is really just going to be 1 over x squared. Minus. Now be careful with this next part because you can only bring the negative exponents to the bottom. So I'll write this one off to the side just so everybody's seeing what's going on. I have 6x to the negative 1. When I put this over 1, I'm only allowed to move the negative exponent. So the 6 actually has a positive 1 for its exponent. So that's staying on the top. And the x to the negative 1 would flip to the bottom and become positive. So make sure you're checking to see if the coefficient, that's 6, has that negative exponent as well, and it doesn't. So it's just going to be 6 over x. The 9 does not get flipped over, but we still want to change it into a fraction. So I'm just going to change that fraction into 9 over 1. And if you look at the denominators, those aren't even fractions, so I can just rewrite it as x squared over 1 minus 9 over 1. So our goal is to just change them all into fractions and then find the LCD just like we did on the front page. So in this case, we have 5 fractions. We have the x squared, the x, and the rest are 1s. So when you go to do your LCD, the number is going to be easy because we know the coefficient has to be 1. So you can put a 1 here, but the 1 doesn't really matter because if you multiply by 1, it stays the same. We really only care about the variables, and what we said on the last problem is you always pick the larger exponent when you're working with LCDs and those variables. So I know I'm going to have x squared as my LCD. So now what I'm going to do is I'm going to multiply every single fraction by that x squared over 1. So I'm just multiplying it all the way through. And if something cancels out, and then we'll simplify with what we have left. So x squared times 1 over x squared. Well, these x squareds are going to cancel out, but that doesn't mean we have nothing left because they cancel out and we still have a 1. So that's just going to be 1 minus, in this next one we had 1x on the bottom, but we have 2 x's on the top. So we're still left with 1x on the top. So we have 1 minus 6x. And then the last part, it's just 9 times x squared, which is going to be 9x squared. All over, well, x squared times x squared is really just going to be x to the 4th minus 9x squared, because we can't cancel anything on the bottom. So now we just factor. And to make life a little bit easier for the top, we've never factored with x squared at the end, so we're going to rewrite it as standard form. So I'm going to make it so it's 9x squared minus 6x plus 1. I just flipped the 9x squared and 1 around because it's just commutative property, so that's okay. On the bottom, we still have that x to the 4th minus 9x squared. So all we're going to do is factor. Let me shrink everything a little bit so we have a little bit more room here. So all we're going to do is factor. So the top part is going to be guess and check. Why did it change to a circle? That was not a circle. Okay. So when we go to do guess and check, we got to split up the 9x squared and we got to split up the 1 into those bubbles. In this case, the easier one is going to be the ones. Now we just have to figure out how to split up the 9x squared. And I'll tell you guys right now, it will be 3x and 3x. Because 3 times 3 will give us 9. And we need our middle answer to be -6. So these ones have to be negative. Because -1 times -1 would give you +1. As far as the bottom goes, we can factor that up as we can actually pull that x squared to the outside, and we'd be left with x squared minus 9. And then you guys should notice that the x squared minus 9 is going to be able to factor down as well. Can I fit it right here? If I write small enough, I should be able to. We'll have x squared times x plus 3 and x minus 3. So in this problem, it's completely simplified down. Everything is multiplication. We just got to check to see if anything could cancel out on top and bottom. And if you guys take a look at this, there is nothing that can cancel out. So we're done. That is the lesson for today. Dude, nobody plays Apex anymore. Everybody's going to be switching over to this Valor like in a week or two. April 7th is the closed beta. Oh, Daisy, you're getting a puppy too? Playing Skyrim. Holy cow, you going old school. The game came out almost, what, 10 years ago now? When did Skyrim come out? I think I still have it for my PlayStation. Came out in 2011. That's crazy. What kind of puppy are you getting, Daisy? So I'm done with the lesson, just to let you guys know. So if you guys have any questions as far as the lesson goes, feel free to ask. I mean, you guys know, once it gets towards the end of the lesson, I know you guys are probably bored out of your minds sitting around all day. So if you guys want to chat for a little bit, I'm okay chatting with you guys. I miss having all the conversations with you guys in class. It's unfortunate that we can't do that. Dude, nobody likes Apex. What are you guys doing? The game is trash. What kind of a dog is that? If I didn't know any better, I thought Daisy was trying to swear, and I really, really thought Nightbot was going to come in and attack her. But I guess I don't even want to pronounce it, because if I try to pronounce it right now, I feel like I'm going to get in trouble. I'm like Googling how to pronounce this so I don't get in trouble. Oh, it's French. So it's Bishpu because it is French. And yes, it is a bichon. They say that is a bichon friché. I took French, so I can speak with that French accent. Katie, that is all my wife and I have been doing is playing Animal Crossing. It is so much fun. I have done so much pixel art, and I have Spider-Man all over my walls right now. It's a high non-cavalier and poodle. Huh. The game, I was talking about it earlier, and some of you guys may have seen that, but I'm going to I want to buy the game. It's called like the Untitled Goose Game. And you are just a goose that wreaks havoc around a town. And it looks like it's going to be so much fun. I'm going to buy that, and I'm going to probably play that this weekend. That's what you're doing, Shannon? I have all the fruit. I can't. Which fruit do you have, Katie? Right now, we have oranges, coconuts, and I think we have cherries. Because my wife and I will play at the same time, so we're trying to make the island. We just got our museum, and I think we've had 4 new people move to our island. Have you played it, Hunter? It looks like it is so funny. I wonder if I can play Skyrim on stream. I mean, it can be violent. If I just avoid all fights, it should be fine, right? I'm trying to see what the rating is. It's got to be like for blood and gore. There's no way I could probably play it. Oh, you guys played it. Do you guys both have your own Switch? Rosie? I don't know which one Rosie is, Shannon. We got, I don't know any of their names. We got some weird squid. And we got a flamingo. We have, man, what else do we have? We have a dog. We have a kangaroo. But yeah, I don't know any of their names. She's a cat. Okay. Interesting, interesting. What do I got? I got 330 right now. Oh, I got you. Did you guys create 2 separate accounts, Katie? That's what we did. We created 2 separate accounts so then we can go around and try to get as much as we can. Trying to see. I'm still trying to learn everybody's names in chat right now, so I keep going back in and looking. And some of them are bots, so I don't know. Like, who's this person? Yeah, what is it? RM, RIM. Yeah, I think it's a bot. I'm typing in a name. That name that I just typed in right there, is that anybody that's actually in chat right now? Oh, I hate people that put TTV in their name, Hunter. I can't stand it. You got to make it big on your own. You can't clout yourself. Yeah, I think that one person's a bot. Everybody else, I think I do know in here now. Well, most of you guys just use your regular name, so it's easy for me to tell. I don't know. What do we got? 335. Well, I'm going to end the stream now. I'm going to do, well, I got to do my math 12 at 4. And then we will be starting Unit 10, Lesson 10 tomorrow, which I don't know. I don't even know what I'm doing for that lesson. I don't know. So just be prepared for a new lesson tomorrow. Hopefully I can upload it to iTunes and we're not going to have any issues. And then we'll go from there. Okay. All right, good, Hunter. I'm glad you do. Anytime I die from a TTV, I go to their page and I become really good friends with them, and I hope that they invite me to a game so I can kill them before the match even starts. But you'd have to have friendly fire on in order to do that. But all right, well, I'm gonna sign off. If you guys missed the live video because you got in here late, you could watch it on Twitch. If you guys have been noticing, I have been uploading everything to iTunes as well. So if you want to watch it on your iPad, you can just download it right on there and watch it, and then you could be good. All right. So I hope you guys have an awesome evening. Don't be afraid to shoot me some messages, and I will catch you guys later. Okay? Homework number 9 due tomorrow at 9 p.m. Or get it to me when you can. All right? All right. Have a good one, guys. See you later.